Hi, Joby. Thanks for the introduction. Hi, Brendan. Hi, everyone. So, what is OpenXSAM? It's probably not very self-explaining, but hopefully by the end of this talk, you will have an idea what this is about and why we think it's important or useful. Let me check if I have the control over the presentation here. Yes, works. So this is about OpenXSAM. We'll get to what it is and why we deal with it in a minute. Couple of sentences about itemis in case you don't know us. We are a software consultancy company, relatively small one, less than 200 employees. Most of our offices are in Germany. And about 30% of the clients that we deal with are from the automotive realm. The common denominator is not so much who we work with, but how we work with our clients, and that is mainly in the area of systems engineering. And maybe Brandon, you want to take over and introduce Block Harbor?
Yeah, thanks, Dirk. So Block Harbor, I founded it back in 2014. We're an automotive security service provider based in Detroit, Michigan. That's kind of where our lab space is, performing activities like TARA, pen testing. We run a 24/7 security operations center. So yeah, we've been in this automotive security game since kind of the inception of this space, serving automakers and suppliers with services in the space.
Okay. Then let's move on. Why are we here? Why do we think that we talk about something important? Well, you might have heard it in one of the other talks, but recently there have been new developments in the UNECE area, and it's basically about the upcoming rules, what you need to do in order to license new vehicle types. And there were two main streams they were discussing. The top topic that you see here, and this is related to ISO SIA 21434, is about implementing a cybersecurity management system. So what does it mean? In order to register new vehicle types in future, and future means as early as summer next year, is you have to prove that you have a working cybersecurity management system in place. And one important aspect of that cybersecurity management system is described in the ISO 21434, and an important part of this is creating threat and risk analysis. So I have to, in a hopefully early phase of the design process, that's a security by design idea, prove that my design is secure, and I have to document this. And this is a lot of work. The bottom part, which we are not going to talk about now, but is equally important, is the software update management system. So I also have to prove that I have a software update management system in place. Because if there are going to be vulnerabilities and I need to change something in the software, I need to know how I'm going to do this. And this is what the bottom half is about. Originally, the discussions and the work around those two topics were organized in work package 29. And the result of those tools are two regulations. And the top regulation ended up being UN regulation 155. And it basically describes what you have to do in order to have a working cybersecurity management system. As I said, this points to ISO 21434. In case you're not familiar with what 21434 expects us to do, it's kind of the equivalent of the ISO 26262 for functional safety. So this is about road vehicle cybersecurity engineering. And there are a couple of steps that need to be followed. We unfortunately don't have the time to go into super details here, but what is important is in clause 8, it says you have to perform a threat analysis and risk assessment. So basically, I have to understand how attackers could potentially attack my vehicle and what the resulting risk is. And if you look at the risk factor, there are mainly two components that go into risk. One is what is the damage that could occur, and that could be financial damage or privacy damage or safety damage as well, and how likely is it? So I have to get a sense of how easy it is for someone to attack the vehicle. And this is what I do in Atara. Now, if we look at the details, and we can't go through everything, but there are a couple of steps that need to be done in order to perform such a Tara. I need to look at assets. I need to look at potential threats. I need to look at the likelihood of threats to be successful. I need to come up with a risk, and I need to define potential controls to mitigate those risks. And if you have the automotive development process in mind, it's highly distributed. It's highly distributed among OEMs, tier ones, tier twos, and it's also highly distributed within a company. So there's an organization, there's a process flow that needs to be followed. You see the steps that are typically taken here. So you look at requirements, design, specification, implementation, and those funny colored boxes here represent tools. So if you come in and you do a Tara, you need to tap into many informations that are distributed across multiple tools in your existing process. And this is only the process of one company. The process of the next company might look slightly different with different tools. So in the past two and a half years, we came across this challenge, how to get information out of existing tools in a tool chain, get it into the Tara process, then perform that threat and risk analysis, and then get the results back, so it will be part of the overall tool chain again. And that turned out to be fairly tricky, because that landscape is different for every OEM and tier one and tier two. So if you have to start from scratch each time to think about, oh, what could a potentially data exchange look like, it's a lot of work that you spend on technical issues and not on the actual threat and risk analysis. So what we came up with as a result is, and since there are so many domains that are affected, so you have a requirements domain, you have an architecture domain, you have security specific domains, you have catalogs, we couldn't tap into one existing format like SysML or RecIF. So what we did was we basically took all the aspects that are required to feed that Tara process and created an XML format that contains all this information. And initially, internally, we called it XSAM. And once we realized that it really makes sense to share this with everyone who is involved in these processes, we converted it into OpenXSAM and made it public. And this is what happened about 6 to 8 months ago. We applied it in many different client scenarios. But this is all kind of theory until here. So I think the important question is, how does that look like in an actual project, in an actual environment? And this is where Brandon could step in and could talk about his vision and his experience with that format.
Yeah, so let me see if I have control, and I do. So Dirk, thanks for that overview, breaking down from the regulation pressure in the space to the standards in the space to Tara, and then exchanging data between tools. So for us at Block Harbor, we've been contributing to OpenXSAM as kind of another party using the data format to feed and output of our tools. So we're going to talk about how we do that in a different part of the ISO 21434 process. So thinking about that same kind of process that Dirk was outlining, on the left of the V model, you're starting with a concept, you're performing a Tara, you're designing good requirements, you get those requirements to a supplier, you work with that supplier to design those requirements into an actual product, and then from there, you are verifying that you are indeed meeting your requirements in your actual product. Then your vehicle goes to production. And as we all know with cybersecurity, this is a circular process because the threat landscape is constantly changing. So this cybersecurity management system, if it's the circular process, you really need this integrated tool chain to become or to be efficient and effective. So what we're working on is the right side of the V, the verification aspects of 21434. We partnered with a company, Keysight Technologies, to develop a platform that takes in cybersecurity requirements that may be outputted from Atara. We set up automated tests with hardware in the loop testing, and then we output this in terms of work products for 21434, and then the regulation that Dirk was pointing to, UNR 155. In other words, a platform to ensure vehicles are meeting their cybersecurity requirements. So this is kind of what it looks like in our lab space, just to put a picture to what I'm saying. We have a test system that's testing real vehicle test benches to ensure that they're indeed meeting the cybersecurity requirements that are being derived in the CSMS. So back to OpenXSAM. Now, we have this platform that is, it's ingesting requirements, testing against the requirements. For us, what we need to do is have a constant feed of the latest requirements so that we can ensure that we're testing the latest requirements. Again, we expect those requirements to be changing. So back to the V model. On the left side, you have something like a Tara platform. That's something that itemis works on. On the right, you have the platform we're working on with Keysight. And then there's a third aspect that I see fitting in here, a monitoring platform that exists when you're in production and operations. Our platform, the verification and validation platform, again, we rely on having good requirements. The sooner we have those requirements input into the system, the sooner we can get either someone testing them or an automated test set up to ensure that the vehicle is meeting it. So the data flow here looks something like a Tara is outputting requirements that would input into the verification platform. You get it verified, you go to the field. You have monitoring platforms that are looking at the latest vulnerabilities to understand if you need to adapt your requirements, especially as you're adding new features and changing the vehicle that will go back into your Tara platform. And then again, you perform your Tara, your risk assessment, and you output that back into your verification platform. This is that circular loop I'm talking about. Now, each of these red lines between monitoring platform and Tara platform, that's where we see OpenXSAM fitting in. And for us in particular, we're thinking about this bottom red line, where you have this real-time update via an open standard called OpenXSAM that allows that contains the requirements and other key aspects from your Tara so that you can verify that effectively. So why do we think this is so important? I think having these kind of interconnected real-time updates between your tools makes the job of securing vehicles easier. I truly can't imagine the processes whereby it's, this kind of manual process of performing a Tara, and then somehow, it gets over to the verification team, and then somehow, eventually the product gets released. I think all of that there's a lot of room for improvement where it can be kind of real-time updates between all these different tools so that you can, to the second point here, you can release these updates and patches more rapidly. You can keep the safety aspects of 21434, a process that forces you to slow down and ask if what you're doing is secure, but you can just make the interchange between tools a lot more rapid. So, that gets to the third point. It reduces your time to exposure. Let's say that you do discover a vulnerability in your product. The question is, how quickly can you engineer that vulnerability out of your product? If you don't have this kind of integrated tool chain, again, ideally through an open format that everyone can contribute to, each of these different tool vendors can contribute to, then it's really, then you spend a lot more time exposed. You're thinking about how quickly can you get patches out to your customers. A fourth point, you can share this data through the supply chain. If OpenXSAM is a format adopted as an agreed upon format between suppliers and automakers, maybe there's an avenue here where an output of a supplier's Tara can input into an automaker's Tara. You need that because suppliers are going to be responsible for performing a threat analysis against their own component. And then the automaker is going to be held liable for that. So they're going to want to know how much risk they're exposed to as well. And so you kind of had this integrated supply chain. Again, an open format really makes a lot more sense for that. And then finally, the last point, to me, this is on everyone's mind. It's that, look, we have to secure the vehicle. I think everyone's got that. Everyone's got that since 2014. But the reality, or the business reality, is that we got to meet these regulations. These vehicles need to be type approved. So if all of your tools are sharing this kind of same format, it makes it a lot easier to sum up that information and give it to the auditors when you're seeking type approval for a vehicle type. So I know that was super fast. I know it went super quickly through how we're applying this OpenXSAM format. I do want to point to this, where if you're involved in this tool chain, or you're an automaker or a supplier who's maybe dealing with some of these processes, and you're asking yourself, hey, how can these tools or processes be more efficient? Consider contributing to this. There's a site on the internet. It's openxsam.io. Check it out. What we're looking for is a community-driven approach to an open exchange format for security assessment models, security analysis models. So yeah, I guess with that, that'll conclude my part of this. Any questions from the audience?
I'm going to refresh. I don't see anything right now. Give me 1 second to refresh, and I'll let you know. Here. I don't see any questions directly from the audience, so I'll go ahead and tee one up for you. As somebody who has worked in the past on automation and controls and DevSecOps flow, is this something that you see is not only just something that helps with compliance towards regulatory requirements, but also something that can be an automated thing to pass from one entity to the other without any sort of human interaction?
Sure, I'll take that one. In my kind of dream scenario here, itemis kind of was Dirk was talking about TARAs. You have this process for identifying threat scenarios, ultimately culminating into identifying security controls that mitigate those risks. I mean, that's exactly how I see it, Joby, is that the second an analyst can have identified that security control, that data can be exchanged with the software developers that may be able to push an update, where then that data can be exchanged with the validation team that can quickly verify it. So that's exactly it. That there's kind of real-time population between tools, that you have kind of the latest and greatest understanding of the security of a system at all times.
Yeah. And maybe to add to this, there's one step in the process where you monitor the field and you might find a new vulnerability. So the question is, how do I update my TARA after someone found a new vulnerability? And the way we see this, and this will be highly automated, is that I can basically, coming from the vulnerability, update values in my control or threat catalogs. And the threat catalogs contain the likelihood or the feasibility for an attack to happen. And typically a vulnerability increases the likelihood that something happens. So the moment I have the vulnerability, I can send out catalog updates in the OpenXSAM format, and I can basically automatically rerun all the TARAs that I did in the past based on the updated catalogs and see if something changed in my risk level. And for those projects where I see a change in my risk level and I need to act, I can then follow up with everything that comes afterwards, from patching software to rerunning tests to redeploying software in a software over-the-air scenario. Because doing this manually, and many of us come from a more Excel-based document static world, yeah, where it can take a couple of weeks to look through something and maybe find a problem or not. But this is you have a problem and you need to find out for probably hundreds of your projects, what does it mean? Do I have to act? And that only goes with automation. And of course, everyone can think about their own format, but is this really where we want to spend our time? I think agreeing on a common format will cut off all this technical overhead and give us time to look at the actual problems, the vulnerabilities out there in the field.
Awesome. Awesome. Thanks, guys. We are unfortunately out of time. I didn't see any additional questions, so thank you again for your time.